A very good morning to all of you. I am Bhavya Gupta, pursuing MSc Honours Mathematics from Punjab University.
And I am Manish Nair, also pursuing MSc from Punjab University, Chandigarh.
We are here with our model, our famous problem, that is time minimizing transportation problem. In this problem, we are given a table in the form of matrix whose entries are time units with 4 destinations and 3 sources with their availability units and requirement units. And we have to chart out a model in which we get minimal time units. This is our time minimizing transportation problem table in which our entries are of time. Matrix elements are time.
And we have 3 sources. From source 1, there are 15 units available. From source 2, we have 25 units available. And from source 3, we have 5 units available. And to the destination, we require 12 units in destination 1. In destination 2, we require 8 units. From destination 3, we require 15 units. And destination 4, we require 10 units.
And it is a balanced transportation problem. Supply and availability sum is equal, that is 45. We have solved it using Vogel's approximation method. From the maximum elements of time units which are of basic feasible plan 1, 0, 11, 9, 16, 18, maximum is 18. So we will first rule out all those time elements which are greater than 18, that is 20 and 20. Now we will form a closed loop.
Starting from 3, because it is the minimum, to 7, to 8, and from a closed loop around it.
We will shift 3 units around it. Why? Because 3 is the minimum, plus, minus, and from 3 and 8 minimum is 3. So value of theta would be 3.
So value of theta will be 3, starting from there.
3 units is shifted around, so 8 minus 3 is 5.
And 3 minus 3 is 0, which is out.
And 7 minus plus 3 is
10.
Now this is our second basic feasible plan. From here, as we have proceeded in our first step, we will see what is the maximum.
So from 1, 0, 9, 11, 14 and 16, we will take out the maximum, which we will denote by capital T2. So obviously 16 is the maximum element. So now the second step will be to rule out the greater than 16, all those which are greater than 16, which is 18.
So we will form a closed loop starting from, that is 16, because it was maximum 2, 13, 12, and theta is added in this position, forming a closed loop. As explained earlier, plus theta minus theta, plus theta minus theta. Minimum is from 12 and 2 is
2.
So theta will be
2.
And 2 units will be shifted around our loop.
So theta becomes 2.
2 is
ruled out,
and our feasible plan becomes this basic feasible cell.
And 13 becomes, because we are adding, 15. And 12 becomes 10.
Now, as we have done earlier, we will see what are the maximum time units
from the remaining we have. From 1, 0, 9, 14 and 12.
11.
and 11, we have,
Maximum is 14.
which we will denote by capital T3.
And we will rule out all those time elements which are greater than 14.
40. So 16 will be ruled out.
In this case, we are left with only 7 and 10 to form a closed loop.
So now we will start forming the loop from 14.
And we will use this cell where theta will come here and here. And our loop is closed at 3.
So now we will, this is plus theta, minus theta, plus theta and minus theta. So we will take out the minimum of these 3 and 10.
And minimum will be 3. So 3 units will be shifted around our closed loop. This will gone out and our plan would be, this would be our basic feasible solution, 3 and 2 plus 3 is 5, 10 minus 3 is 7, and hence this is our basic third feasible plan.
So now we will take out the maximum time from the remaining part from 12, 1, 7, 0, 11, 9. So the maximum is 12.
And hence greater than 12 time units, that is 14, will be ruled out. Now we are left with only 10 and maximum is 12. So from 12 we have to form a closed loop such that it tends to 0. But how we will form a closed loop, because we are only left with 10 and we cannot form any closed loop. Hence this is our optimal basic feasible plan for time minimizing transportation problem, and our units will be 12 time units.
Thank you everyone. So this was our solution.
That is 12 time units. Minimal time minimizing transportation problem.